The coin's design is created by skilled artists and engravers, either in-house at the mint or contracted from external design agencies. The design is typically created using computer-aided design, CAD, software. Since these designs are drawn on large digital canvases, they allow the artist or sculptor to make precise detailing and adjustments. The approved design is transferred onto a larger metal piece called a master die, through a process known as hubbing. The master hub is made from hardened steel and contains the raised mirror image of the coin's design. Since the relief or image on the master hub is positive, if it's used to strike a coin, the coin's image will be negative or reversed. To avoid this, several working dies are created from the master hub. Each die can produce thousands of coins before wearing out, so multiple dies are created to accommodate large production runs. Each country has its own set of guidelines for the composition of its currency. The vendors who supply the metal or stock to the mints must follow these guidelines to the letter. While gold, silver, or bronze were the coinage metals of the ancient world, these days most coins are made up of nickel, copper, or aluminum. On top of being cost-productive, these metals are also resistant to corrosion, which allows them to maintain their shape over extended periods of circulation. Additionally, copper's electrical conductivity is useful for coins used in electronic transactions. In the factory, strips of copper, nickel, or zinn are ready to be turned into coins. Each strip is about 1,500 feet long, which equals the length of 5 football fields. Coin blanks, also known as planchets, are produced from metal strips of the appropriate composition, such as copper, nickel, zinc, etc. The metal strips are fed into a blanking press, which punches out round discs with the precise dimensions of the intended coin. The blanks may undergo annealing, a process of heating and cooling to make them more malleable and reduce the risk of cracks during striking. The perfect blanks are carried by conveyor belt to the coining press, where they are stamped with designs and inscriptions. A steel collar is inserted into the press around one of the dies. The die for the reverse side is loaded into the upper arm of the press. Hundreds of tons of air pressure push the blank into the collar. At the same time, the overhead die is forced down into the collar and onto the blank. The impact causes the impressions to form on both sides of the blank. The press releases the newly minted coin and it moves along a conveyor belt to the inspection line. In some instances, the collar has grooves to make the rigid edges on the coin. Otherwise, the grooves are made after the striking process on a tool called an upsetting mill. The size of the press varies from single capacity to ones that stamp 4 coins simultaneously. Single striking presses generally stamp 400 coins per minute, with pressure loads up to 180 tons. Multiple presses can crank out 120 coins per minute under 250 tons of pressure. After striking, the coins are visually inspected and undergo quality control checks. Automated inspection machines can detect and remove defective coins. The freshly minted coins may go through additional processes for finishing touches, such as burnishing, electroplating, or applying protective coatings to enhance their appearance and durability. The minted and finished coins are counted and sorted into batches. They are then packed in rolls, bags, or other containers suitable for distribution. The coins are distributed to banks, financial institutions, retailers, and collectors. In some cases, the coins may be shipped internationally to meet demand in other countries. As digital payment solutions and electronic transactions continue to gain popularity and advancements in financial technology, fintech, reshape how people conduct transactions, it's not long before coins become a relic of the past. Once the tuna is caught, it is brought aboard the fishing vessel. The crew immediately begins the critical process of handling the fish to maintain its freshness and quality. This involves bleeding the tuna to remove the blood and gutting it to remove the internal organs. In some cases, tuna is pre-cooked on board the fishing vessel to preserve its freshness until it reaches the cannery. Pre-cooking is achieved through quick steaming, which partially cooks the fish and helps retain its natural flavor and texture. To maintain the tuna's freshness, it is quickly chilled or frozen after onboard handling. Chilling involves storing the fish at low temperatures, while freezing entails subjecting the fish to sub-zero temperatures. Chilled or frozen tuna is then transported to the cannery to undergo further processing. Once at the cannery, the tuna undergoes thorough quality checks to ensure it meets the required standards for processing. This includes assessing its freshness, size, and overall quality. If the tuna was frozen during transport, it is first thawed before further processing. The thawed tuna is then deboned, removing any remaining bones to produce boneless tuna fillets or chunks. The deboned tuna is cooked to ensure food safety and prolong shelf life. This is done by loading the tuna into metal racks, which are wheeled into large steam pressure cooking chambers called retorts. Tuna is baked for a prescribed time and temperature, depending on the size of the fish. This steam baking removes excess oils, and the high pressure and temperature effectively sterilize the fish and eliminate harmful bacteria. The cooked tuna is carefully examined, and any damaged or inferior pieces are discarded. The selected tuna is then categorized based on the desired canned tuna product, such as solid white tuna, chunk light tuna, or other varieties. The selected tuna is now ready for canning. Cans are filled with the cooked tuna along with the chosen medium, typically brine, a water and salt solution, or oil. The amount of tuna and the type of medium are regulated to achieve specific product characteristics. The cans are sealed tightly to prevent air from entering and to maintain product freshness. The sealing process involves securely attaching a metal lid or top to the can, ensuring it remains airtight. The sealed cans undergo a process of heat sterilization to destroy any remaining bacteria, enzymes, or microorganisms. This step is vital for ensuring the canned tuna's safety and extending its shelf life. After sterilization, the cans are rapidly cooled to a safe temperature. This helps retain the tuna's quality and prevents any further cooking that could affect the product's texture and taste. Once cooled, the cans are labeled with essential information such as the product's name, expiration date, nutritional content, and branding. The cans are then carefully packed into cartons or boxes for shipping and distribution. Throughout the entire production process, strict quality control measures are in place to ensure that the canned tuna meets industry standards and regulatory requirements. Samples are regularly taken for testing and analysis to verify the product's safety and quality. The packaged and labeled canned tuna is now ready for distribution to retail stores and other markets. The product is shipped in controlled conditions to maintain its quality and freshness. Canned tuna once held the title of America's most popular seafood. According to data collected by experts, tuna held that title for 50 years, 1950 to 2000. During that half-century, more than 85% of American households had tuna fish stocked away in their pantry. Though its popularity has not lasted into this century, the market is still expected to grow, with revenues rising from $8.57 billion USD to $11.89 billion USD between 2020 to 2027.